Hello again. Thanks for joining us. This is Space Nuts, where we talk astronomy and space science. And it's good to have your company on this, a Q&A edition. And what are we talking about today? Oh, something completely different, new and unchallenged in the annals of Space Nuts and the wider world of astronomy. Somebody's got a black hole question. And the next question is a dark matter question. They just dovetail beautifully, those two. And then we've got a bit of a Dutch treat for you. Robert from the Netherlands is asking about the Fermi paradox, and Angela from the Netherlands has an idea to send bugs into space on purpose. We'll talk about all of that on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us again to solve all of those little riddles is Professor Fred Watson, astronomer at large, still wearing the same shirt as he was last. Hello, Fred.
Yeah, I only change my shirts once a week, apparently.
Yeah, well, I do that on holidays because you don't get to. Although on our cruise we did all our own washing because they charge you to do washing on a cruise ship if you want them to do it. But they had laundries on this ship, so we did our own, which turned out to be a very good thing. So it's sort of.
You're on board for 13 weeks, weren't you? 13 weeks is a little bit long to keep the same shirt on.
Yeah, basically, it's pretty tough wearing the same pair of undies for 13 weeks and expecting people to actually sit down and have dinner with you. It's not advised. Not advised.
Oh.
No.
You sound so you tried it, actually.
No, I haven't.
No, I haven't. Your wife wouldn't let you do that, then.
No, definitely not. Now, we've got a bunch of questions to get through, and we might as well get the ball rolling with Dave, who has a question related to black holes.
Hey, Professor Fred Watson, Andrew, and or Heidi, whoever this may be. Got a question about black holes, like all my other questions. I've been watching a lot of documentaries, and something that still questions me is black holes, do they move or are they stationary? And if they do move, do they move through space and time or space-time like the fabric of space? And if so, are they eating the fabric of space, or is it just going around the black hole and then back into place? How come we don't see trails behind the black holes where they've just eaten away fabric of space? Not quite sure how that works or anything like that. And if they all do rotate, which we think they do they rotationally pull on the fabric of space? Thank you.
Okay. Great question. Thank you, Dave. And we'll get a great answer now. Although it's an interesting question. From my perspective, and I think we have touched on this before, everything moves in space. Nothing is standing still, is it?
No, you're right, Andrew. That's exactly the answer I was about to give. And
okay. Thanks, Dave. Next question comes from.
Let's just cover Dave's last part of that question first, which is
trails.
If black holes are rotating, does space-time do they drag it round? And indeed they do. It's a process called frame dragging. The Earth does it, actually. So any rotating object drags the framework of space-time around with it. And I think the same happens with black holes. I think we covered a story probably a couple of years ago, maybe, Andrew, which was about a demonstration that rotating black holes do exhibit frame dragging, that space-time does sort of get dragged around with them. Having said that, then the idea of black holes moving through space is not, I guess, that difficult. And indeed they do, exactly as you've said, Andrew, everything moves. And it's twofold. One is that they're being carried along by space itself, what we call the Hubble flow, which is due to the expansion of the universe. And I think Dave touched on that by talking about, the fabric of space-time. Yes, the fabric of space-time itself is moving and takes stuff along with it. But galaxies, we know, have what we call peculiar velocities. They actually move around within the moving fabric of space. Excuse me, the analog that we often give is to liken the expansion of the universe to a river flowing, and the galaxies being like people zooming around the river in boats. They're being carried along by the river flow, but they still move around with their own peculiar motion. And galaxies do that too. Not perhaps zipping around quite like boats do, but as they're drawn to one another by their own gravity. So they do move through space, and yes, a black hole will move through the space-time that it's in, but it won't leave a trail behind it. The space-time bends around it, just as Dave suggested there. As it goes through, it's distorting the space-time, but, the space-time sort of recovers as it's gone past. So it's not like there'll be a wake that we could look for trailing behind supermassive black holes. Interesting idea, though.
Yeah. It'd be so easy to find them if they left trails.
Yeah, that's right. It would.
That's how you chase snails, if you're a snail hunter.
Well, I'm sure you do. Yeah, we get on damp days, we occasionally get invaded by slugs in our laundry, and they leave trails as well, which are based.
Yeah, where were we the other day? And walked outside because it had been raining, and there were slugs the size of sausage dogs. They were enormous. It was in the United States somewhere, up around Buffalo, I think, somewhere that.
Yeah, probably, yeah.
Big boogers. Oh no, was it Niagara Falls? It was Niagara Falls. They were like this, like you could wrap them around your head if you were so inclined.
Get a decent meal out of one of them.
Oh yeah, yes. Yum. Although that reminds me, while we were overseas, I think it was when we were in Spain. Listen to me name dropping. One of the staff on the ship was doing a presentation about our next stop, and she said, "While you're there, go and get some of this stuff." And it was like a skin cream that had snail slime in it. Okay. My wife bought some and is still using it. She thinks it's fabulous. So there you are. There's something to that. Go and rub snails on your face. And by the way, that story you referred to from a couple of years ago was about frame dragging of supermassive black holes. Was May 2024. There you are.
Okay. There you go. The memory's not quite gone yet, but it will eventually.
I do recall us talking about it. Thanks, David, for your question. Today's episode of Space Nuts is brought to you by Insta360, the clever folks who make those mind-bending 360 cameras and action cams. And now they've gone pocket-sized with their brand new Insta360 GOUltra. Now, when I say pocket-sized, I mean it. This thing is about the size of an Oreo. And yes, I checked, you can still eat an Oreo in one bite, but don't try it with this camera. At just 53 grams, it's so light you'll forget it's even there until you see the footage. We're talking silky smooth 4K at 60 frames per second. Not bad for something that lives in your pocket. And it's not just small, it's smart. With a magnetic mounting system, you can clip it to your shirt, your hat, or even stick it on your bike, a street sign, or your fridge if you're filming an action-packed sandwich-making tutorial. It's built to grab unique angles without the fuss. The upgraded sensor means your shots look amazing, day or night. It's also waterproof down to 33 feet, so you can take it swimming. Just don't expect it to rescue you if you drop it overboard. Battery life? The standalone camera gives you about 70 minutes. Add the action pod and you're up to 200 minutes. And here's the kicker. With fast charging, you can go from 0 to 80% in just 12 minutes. That's literally grab a coffee, come back, keep filming. Lose it? No problem. It works with Apple Find My. And here's the sweetener. For the first 30 Space Nuts listeners, Insta360 is throwing in free sticky tabs so you can mount it pretty much anywhere. Jackets, backpacks, you name it. Just head to store.insta360.com. Use the code SPACENUTS and you're set. Links are in the show notes. Check it out. The Insta360 GOUltra. Small camera, big fun.
0G, and I feel fine.
Space nuts.
Our next question comes from Jared in Melbourne. Hi, Fred, Heidi, Hugh, Dave. Just kidding, Andrew. Thank you. They haven't forgotten the Dave thing, have they? They haven't let that one go. Thought 3 months away, that one would die its natural death. But no, it's just popped itself up again. We talk about galaxies having halos of dark matter gravitationally bound to them, thus affecting their rotational rate as compared to the predicted rotation rate's center edge. Yeah, okay. So then while wondering if the sun has a portion of dark matter gravitationally bound to it, I read that people think it's not much of a halo at all for something like the sun, as dark matter particles are moving too fast to be captured by the sun. I'm very interested to know why people might expect dark matter to be moving too fast to be captured by the sun when we have so few insights about what it is at all. How do they conclude it's whizzing around faster than escape velocity? Keen to get your thoughts. Keep up the great work. Jared from Melbourne.
And a great question, which doesn't really have an answer.
Okay.
And that's because we know so little about dark matter. It's certainly the thinking a few years ago was that dark matter halos have a minimum size, or blobs of dark matter have a minimum size. And as Gerard suggests, that would be related to the velocity of the dark matter particles. What that minimum size would be. If the faster the particles are moving, the bigger the blob of dark matter. I seem to remember a number being touted around, which was about 100 parsecs. And a parsec is, 3.23 light years? I can never get the exact number. It's about 3 light years. So roughly 300 light years. However, I think there have been more recent observations that suggest that it might be clumpier than that it might clump together on smaller scales. However, having said that, I think it is probably unlikely, though, that the sun itself would have its own lump of dark matter. I think the sun's neighborhood and the spiral arms that we're embedded in might have higher density chunks of dark matter than perhaps the outer halo of the galaxy. But if those early measurements are anything like realistic, then it would be on a scale of hundreds of light years rather than hundreds of millions of kilometers, which is what you'd need for it to be bound to the solar system. So we don't really know the answer to your question, Gerard, but people do think about it. It's one of the big issues. And one of the challenges is how do you map the biggest or smallest chunk of dark matter when the best way to see it is to look at the distortion effect of, say, a cluster of galaxies in the foreground and look at how that distorts the images of galaxies in the background, because the distortion is due to all the mass in the cluster, not just the mass you can see. That allows you to map the dark matter in a cluster. But it doesn't really, unless you've got some very special circumstances, it doesn't really make it easy to say just how big or small the biggest lump of dark matter, the characteristic lump size of dark matter might be. So we're still working on it. And maybe we'll get back to you when we know the answer.
Yeah, well, you never know. A parsec is equal to 3.26 light years.
I think I said 3.23, didn't I? And that's wrong.
Well, it's close.
3.3, it's close, yeah. I can never remember the last number in that. 3.26. It's easy to remember because 3 times 2 is 6, so that should tell you, shouldn't it?
Well, there you know.
I don't know. All I've got to do is remember that.
I'll test you next week.
Thanks, Dave. Thanks, Dave. I always appreciate your tests.
Okay. Thanks, Jared, for your question. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Space Nuts.
Now, welcome to the Dutch part of our show, where all the questions come from the Netherlands. And the first one is from Robert.
Hey, Professor.
No, it's not. This one is.
Hello, Fred, Andrew, and Heidi. This is Robert from the Netherlands. I have a question about the resolution to the Fermi paradox. What will be the most credible answer to this conundrum? Is it because the rare Earth theory, that their civilizations of aliens are very, very rare? Are they very hostile and they will destroy everything around us? Are they simply too far away and they stop expanding after a couple of planets? Or are we alone in the universe? I would love to hear the professor's opinion on this. Thank you so much.
Thank you, Robert. It brings up that age-old question, which I'm sure you were going to ask. Question: where is everybody?
Well, that's right. That was that's the basis of the Fermi paradox.
Yeah,
asked in 1950, and the logic, Enrico Fermi's logic was, if you have spacefaring civilizations which evolved, maybe a few billion years ago, then there should be evidence for them everywhere. And we don't see it. We don't see any evidence. That evidence might be in the form of artifacts, if they've sent things into orbit around, the solar systems, and there's at least one person on our planet who thinks that's happened already. Avi Loeb with some of these extraterrestrial asteroids and comets, probably all three of them. Anyway, but we don't have any real evidence that that's the case. And I think I would lump together Robert's first and last options there, where he spoke about the Earth being incredibly, or Earth-like conditions being incredibly rare, so that intelligent life might be incredibly rare, or his last option, that it's unique, that we are unique in the universe. Those two are not that different from one another, because either way, if you've only got one civilization, communicable civilization per galaxy, and then you might as well forget it. You're alone in the universe, basically. Which I think is, that is disturbing, because it means, if we wipe ourselves out, or if we become extinct through whatever process, we are how the universe thinks about itself. That's I think that's a quote from Brian Cox. Life is what lets the universe understand itself. And if we're gone, and we're the only species in the universe that can understand it, what's the rest of it for?
Well,
it's all a bit of a pain.
Well, yeah, but it brings about, you can get into areas of theology then, and that's one idea that is well documented and well supported. Creationism. We could just be one freak accident that happens.
That's right.
And the universe existing in itself is the greatest mystery. How is their existence? I think I've asked that question before, and no one's ever told me the answer.
It's a philosophical question. That's
it is, and it is.
Yeah, I mean, it's there's a quantum physics answer to that as well. If we weren't there to perceive the universe, would the universe still exist? Because in quantum mechanics, it looks as though the observer plays a significant role in the nature of reality. And that's why scientists are constantly looking for a theory that underpins both quantum mechanics and relativity, the grand unifying theory, which we haven't got yet, that might tell us whether the observer is necessary in terms of the well-being of the universe. It raises extraordinary questions. But I think it's certainly my thinking, and this comes from talking to astrobiologists who think, that step from single-celled organisms to multi-celled organisms could be a really rare step, then perhaps we are very rare. Perhaps we are a freak of nature. I would lean towards that rather than the idea that life is everywhere, and think that the answer to the Fermi paradox, where is everybody? Well, they're just not there. Most of them. Yeah. They're not there.
Well, there may not be peoples, but there may be bacterial life of some kind.
Yeah, that's right. But and that might turn out to be quite common, but it needn't necessarily evolve into anything more substantial.
No, definitely not. And if you're looking for aliens, as you said, if they've been around long enough, we should see the evidence, whether it be a passing spacecraft or a megastructure of some kind that we might see around a planet or a star, or a conspicuous gas in their atmosphere that couldn't be natural, things like that. But we haven't found any of that.
Airport radar, all of that.
Yes, airport radar.
Yes, square kilometre array able to detect airport radar at 50 light years. So once it comes on stream, well, we might know we're alone within 50 light years.
Yeah, well, that is it, exactly. So, Robert, no, yes, we're still alone at this point in time, and yes, and we're feeling it. We really are. But I sort of err on the side of caution when it comes to revealing our presence. I'm a little bit with
Stephen
Hawking. You don't want to make too big a noise just in case they go, oh, that's a lovely place, we'll have that. That's what the British and the Portuguese did. So and the Dutch. Oh, no, the last two people are Dutch. My wife's Dutch, so I can get away with things like that.
And
the French. I mean, the French did it too.
We're already, we've already given it away because we've got airport radar.
Yes, we have. Yes, we have. Thanks, Robert. Great to hear from you. Time to take a break from the show to tell you about our sponsor, NordVPN. If you're online, your data is always at risk unless you take some sort of action to secure your exposure. And a virtual private network is the way to go. There are lots of hackers and trackers and unsecured networks out there that just make you an easy target. And it happens without your knowledge. It always happens very quietly and in the background. And that's what makes it so nasty. And that is also why using a trusted VPN like NordVPN is a pretty smart move. NordVPN keeps your internet connection secure and private by encrypting your data and hiding your IP address. And that means you can browse, you can stream, you can shop, you can work online without worrying about who might be watching. It works seamlessly across all your devices, and it is one of the fastest VPN services available, so you won't sacrifice speed for security. And right now, as a Space Nuts listener, you can get an exclusive offer, big savings on NordVPN plan. You get an extra 4 months for free, and all you have to do is sign up. Don't forget, they've got a 30-day money-back guarantee, so you can test this out for yourself before you fully commit. But I've been using it for years now, and I've got no complaints. So go to nordvpn.com/spacenuts, nordvpn.com/spacenuts. Take control of your online privacy today. Easy to use, powerful protection, no hassles. nordvpn.com/spacenuts. And don't forget the code word spacenuts at the checkout. Now back to the show.
3, 2, 1.
Space Nuts.
And our final question comes from the Netherlands, and it's a text question from Angela. I learned from earlier episodes that any item sent to space must be sterile, free of bugs. This is to prevent contamination of the celestial bodies. However, could we consider the opposite? Send bugs, seeds, bacteria, etc. out into space on purpose. This will give life a small chance to evolve somewhere else and escape the potential one and only planet in our Milky Way that contains life. Kind regards, Angela from Amsterdam. So she's sort of going on from what Robert was talking about. We've got evidence of life on one planet, but she's saying, well, why don't we go seeding the other planets? Let's not keep our spacecraft clean. Let's just line people up. You can all hock on the spacecraft and off it goes. And we see the universe. Look, it worked in South America. The Spanish took all their nasties over there and nearly wiped the people out. So,
okay. Yes, that's right.
Yeah.
I mean, to some extent, this has already happened because I think it was the Beersheba spacecraft, which was a private Israeli venture, which crashed on the moon, carried fruit flies, it carried tardigrades, carried a few other things. They presumably perished in the accident. But the question I would have for Angela, I mean, yes, okay, you fill a spacecraft full of earthly creatures. It's a bit like Noah's Ark, really.
Yeah.
2 by 2. You seal it so that it's not gonna destroy another planet or seed another planet if it crashes. So you make it crash proof. But then you've got to sustain these organisms to keep them alive. And that's a tricky mission. How do you, if you're talking about lengths of time measured perhaps in millions or billions of years, which is how long it might take to land on another world in another solar system, how do you keep things alive for that long?
I've got the answer.
Have you? Oh, good. I've
got the answer. When I was growing up, they were selling sea monkeys at toy stores. Yeah.
Yep.
You bought the packet.
Yep.
You filled a jar full of water. You tipped the packet in, and then all these things came to life. All sea monkeys.
What were they?
Don't know. Krill. Probably something like that. They were some kind of little crustacean. Hang on, I've got to look it up. I honestly can't remember what they were.
Tardigrades are a bit like that because tardigrades can dehydrate themselves completely. That's how they've survived on the outside of the space station. But once you...
Brine. I was right. They were shrimp. Brine shrimp were sea monkeys. Yeah. They were developed in the United States in 1957 by Harold von Braunhut and sold as eggs intended to be added to water. And you used to buy them and take them home, put them in the water, and they'd hatch, and you'd have sea monkeys. There you are. So there's the solution.
Now, how long did they last once you put them in water?
5 minutes usually. They did. No. I don't know. They didn't last.
Yeah. So it doesn't. Okay. Yes. So it doesn't really give you much time to start a new population of species from planet Earth.
Probably not.
If you find water on another world. Yeah. I mean, it's, and of course, there's an ethical side to this as well. My answer to, it's the answer to why we sterilize spacecraft going to Mars, because we don't want to contaminate Mars with earthly microbes. If there are microbes there of Martian origin already, you don't want to intermix them.
So Angela, he had to do that. He just had to do the ethical thing. You and I are on a different page, but yeah.
Well,
we're coming from Angela.
Yeah.
But if the Fermi paradox is what it is, then why are we worried anyway?
It doesn't matter. That's right. It just doesn't matter. Yes. Can send anything anywhere. Yeah. Well, that might be the way it ends up if we never find any evidence of life somewhere else. But I think this is a study that's still in its infancy. Astrobiology has only been around for 30 years or something. So we've still got a long way to go. We have, yes. Yes, at this stage we're playing it safe. I think the day will come, Angela, where we'll load up an Ark spacecraft and we will send them hither and thither and try to populate another planet. Who knows? Could happen. Thanks, Angela. Great question, though. Really enjoyed mincing that one up. And that brings us to the end of the show. Fred, thank you. Thank you, Andrew. Thanks for your tolerance and patience. And I think it's the other way around, Fred. But anyway. Thanks for not dropping out on me. Yes, we've had a golden run today. Yeah, it's been good.
after the massive false start. But yes, we were all good. Thanks, Fred. We'll catch you next time.
Sounds great. Thanks, Andrew.
Professor Fred Watson, astronomer at large, with us every week, twice on Space Nuts. And thanks to Hugh in the studio, who couldn't be with us today because he's just putting his Dutch nationality application in. He's sick of being a Kiwi. He wants to be Dutch because, they're so cool. Well, I married one, so there must be. And from me, Andrew Dunkley, thanks for your company. Catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.